So before we start this unit, we need to go back and remember some things that we've been doing before, right, Mr. Dmitrievich?
Been a while, hasn't it?
Yeah. So we want to talk about how to name. So when we're doing naming, if you recall, there are two main categories of naming compounds, right? There is naming covalent compounds and naming ionic compounds, right? So if you've got a covalent compound, Mr. Dmitrievich, what does that mean again?
It really just means you have two non-metals that are together. And we can see those in the upper right-hand corner of a periodic table.
Right, and so if I've got covalent compounds, it's non-metal to non-metal, and in this case, guys, what we're going to have is we're going to use the Greek system. Remember, that's mono, di, tri. Now, when we're naming ionic compounds, Mr. Dmitrievich, that's what?
That's a metal and a non-metal, or a metal and a polyatomic ion.
Right, and there we use what system? We're not using the Greek system, we're going to use the
Roman system.
The Roman system, right? That's where we say iron 3, Roman numeral 3, chloride or something like that. So let's just do a few examples and just, it'll recall, because you've done this before, but you probably are a little rusty on this. So, Mr. Dmitrievich, I'm just going to do some random ones, and we're going to try and figure out what type of naming system to use. So, first one we want to do is FeOH3. So, what are we going to do?
Well, we take a look at the metal, and the first thing we look at is it in our periodic table in the transition metals or underneath the staircase? Right. And in this case, Fe is. So we know it needs a Roman numeral.
So first, we're going to write a first name. So first of all, it's ionic, metal to non-metals. And so it's going to be iron. And since it's OH, it's a polyatomic ion. So we have to look that up on our polyatomic ion list, right? We've got that right here, polyatomic ion list. You want to pull that out. And OH, what's its name?
It's hydroxide. And
since this is iron something hydroxide, since this is a transition metal, we have to figure it out. So if you recall, we often do this Fe, OH, OH, OH. And how do I find the charge of the OH?
Well, we have it right now on our polyatomic ion table, and so we know that each OH is a minus. And so if we have three minuses altogether, we must therefore have three pluses, and since there's only one Fe there, that must therefore be a 3 plus. So the Roman numeral we choose is Roman numeral
iron 3 hydroxide. So remember how to do this. Let's do this in reverse. Let me say that I want to name cobalt 2 nitride. Again, copy down these examples in your notes. So cobalt 2, now we wanted to write the formula, so it's kind of the reverse, right? Symbol for cobalt, look on your periodic table. Mr. Dmitrievich, I know you know the answer.
It's CO, and we love when we see a Roman numeral, don't we, Mr. Bergman?
Yeah, because the charge is?
Well, it's going to be 2, because whatever the Roman numeral is, it's 2.
Now, nitride is a little tricky. You don't use the polyatomic ion list, because that's just going to be what?
That would be an N. And
with
then you
charge
have to
of?
look and yeah, it's going to be a 3 minus, but if you remember, you take a look at the periodic table and see what column it's in, and if you count over, it's going to be in the 3 minus column, so therefore it's going to be 3 minus.
So now I need to make them so they add up to 0. Now that's positive 2 and negative 3, so I can say N negative 3, CO positive 2, it's not negative 6, right guys? Positive 2, positive 4, CO positive 2. So I've got 3 COs and 2 Ns, so I simply will write CO 3 in 2. All right, now you're going to do some examples in class. Now, let's do a couple other ones. What if I want to name SO2? What's the name of SO2?
Well, if you take a look right there, you notice that it's not a polyatomic ion, so there's no negative there. And if you take a look as well, there are two non-metals. We have an S and we have an O, and they're in the upper right-hand corner of the periodic table. So that means we're going to have to use the Greek system with mono, di, tri, etc. But the trick is the first element, we always write the name of it down. And if there's only one of it, we never put mono in front of it. We would just say sulfur as opposed to mono.
And then 2, the prefix is di, so this is sulfur dioxide. Simple. Let me do one last one, guys, and then you're going to just practice. I want to just, how would I name I2? Yeah, a little tricky. It's just simply iodine. Now, but what's the deal with the 2, though, Mr. Dmitrievich? Why is there a 2 there?
Well, you remember we talked about this last unit where we talked about Brinkelhoff. There are some elements that exist in nature in pairs. So Brinkelhoff, B-R-I-N-C-L-H-O and F, all of them, when they're by themselves in nature, they exist as pairs, and it's because it makes them more stable.
Right. So if you ever get like, you have to write down the formula of a element that has a 2 in it, it's probably just the name of that element. But remember, that only applies to the Brinkelhoffs, but the I is one of the is the I in Brinkelhoff. All right, folks, now you're going to work on how to just kind of regenerate, redo this stuff. That sucks. Okay. So that's it, folks, for a quick review of naming.
See you next time.